So this is going to be a short example of this theorem. And rather than looking at the details of what this is saying, let me go ahead and draw a picture here. We're going to start with 4 points, P1, P2, P3, and P4. And we're going to take an arbitrary point A0, and we're going to rotate around each of the points in order. So P1, then P2, P3, and then P4. And we're rotating by 180 degrees. So we're going to go around P1, then around P2, then around P3, and then around P4. So let me just show you the results. So I went from A0 to A1 by rotating around P1 180 degrees. And then from A1 to A2 by rotating around P2 180 degrees. And then from A2 to A3 by rotating around P3 180 degrees. And finally, from A3 to A4 by rotating around P4 by 180 degrees. So that takes me from A0 to A4 after doing 4 rotations. Next, I want to start at A0 again. I'm going to call it B0. And I want to do rotations in a different order. I'm going to go around P3 first, and then P4, and then P1, and then P2. So I'm going to rotate this B0, I'm calling now, around P3, and then around P4, and then around P1, and then P2. So let's see the results of that. So I took B0, I rotated around P3 to get to P1, rotating 180 degrees. And then I rotated 100 degrees around P4 to get to B2. And then I rotated around P1 180 degrees to get to B3. And then I rotated around P2 180 degrees to get to B4 equals A4. So that's what we're trying to show, is that if you do both of these, you end up at the same spot. It does make a difference which order you do the P's in, but if we do the order P1, P2, P3, P4, and then do the rotations P3, P4, P1, P2, we end up in the same spot. So that's what we're trying to show. So here's what the problem said, and this was the picture we just had. And again, I don't necessarily care to look at all the wording there, but you get the idea of what we're trying to show. Let me just fit in some room to write here. So let me write, we have, let me call it F equal to a rotation. We want to do a rotation around P1 by pi, and followed by rotation around P2 by pi. So this one would be pi P2 here. And then we have a rotation of pi P1. So this is a rotation around P1 by pi, followed by a rotation around P2 by pi. And let's look at G also, which would be a rotation around, I'm going to do the P3 first and then P4. So I'll put P4 here, and then rotation here around P3. So the P3 comes first and then the P4. So both of these are double rotations. And what I want to do to A0 is I want to do F and then G. I want to rotate around P1, P2, and then P3 and P4. And what I wanted to do to the B0 was do G and then F. I'm going to rotate around P3 and then P4, and then P1 and then P2. So what do we know about F and G? Well, the sum of the angles in both cases is 2 pi. That's an integer multiple of 2 pi. It's 2 pi times 1. So both of these are translations. So let me just call this translation by U, say. And let me call this one translation by some amount V. So what we're doing to A0 is we're doing the translation of U and then followed by a translation of V. So TV, TU, A0. That's what gave us A4. We did the rotation around P1 and P2, which was this translation, followed by a rotation around P3 and P4, which is the translation by V. For B0, we did a translation by V first to get to B4. And the translation by V again meant that we were doing the rotation around P3 and P4 first, and then a translation with U around P1 and P2. So this gives us then the information of how A4 and B4 came about if we think in terms of translations. But the point here is that if you take a translation by U and then V, that's just a translation by U plus V. Why? Well, what does this translation mean? I'm translating by U. That means I'm adding this as a vector U to every point, because you want to go in that direction, that amount. So if U were equal is AB here, I'd be going A in the X direction and B in the Y direction for every point. So I'm just adding the vector U to every point. And here I'm adding the vector V to every point. So you're adding the vector U to every point, followed by adding the vector V to every point to see where you're ending up. And U plus V is the same thing as V plus U. So whether you do the translations in this order or this order, you're going to end up with a translation by U plus V, just the sum of the vectors. So in both cases, these are the same. So if we translate by U plus V A0 here, we're getting to A4. Well, this was A0 as well, so we have to end up at A4 as well because this is T sub U plus V, both of these. So that's the argument, that we're just translating by the same